previous sessions, we have discussed about almost all structural isomerism. So today I'm going to discuss double bond equivalent. Otherwise, you can say it is index number or index of hydrogen deficiency or DBE, double bond equivalent. By using this, we can find total number of structural isomers, maybe chain isomers, maybe position isomers, or functional isomers, or metamers, like that any or ring chain isomers, that we can include all structural isomers except tautomers. If they ask including tautomers, then we can include. Otherwise, should not include tautomers in structural isomerism, because tautomerism is one of the types of or special type of functional isomerism only. Tautomerism is a special type of functional isomerism only, so that it should not include tautomer in total number of structural isomers. If they ask, we can include and we can count total. Okay, here double bond equivalent D B E, double bond equivalent or index number or index of hydrogen deficiency. So for this I am writing formula first. Here it is equal to sum of n, sum of here n into v minus 2, v minus 2 by 2 plus 1. This is the formula for index number. Here where n equal to number of atoms, where v equal to valency in free state, So here this is summation, sum of n into v minus 2 by 2. This is the formula for getting double bond equivalent, otherwise index of hydrogen deficiency. So by using this, we can expect a total number of structural isomers. N value here, this double bond equivalent, it should not be negative and it should not be fractional. It should not be fractional value. It should be always positive value, this number. So here double bond equivalent, if you get double bond equivalent as, for example, for given compound DBE equal to 1. What it mean? DBE equal to 1. If you get DBE 1, then the meaning of this is it may contain the molecular formula. You know, isomer means, or isomerism means what? It's a phenomenon in which different compounds are there with same molecular formula or identical molecular formula. So for one given molecular formula or identical molecular formula, how many structural isomers are possible, we have to expect by using double bond equivalent. Means it may contain double bond, it may contain triple bond, it may be ring, it may be straight chain compound. So like that we have to expect. So if you get double bond equivalent equal to 1, it means that may contain one double bond. It may contain one double bond, or it may contain ring component may be. Here two rings are not possible, two double bonds also not possible, even one triple bond also not possible. So we have to try writing different structures with respect to this. It may contain one double bond. We have to try to write one double bond containing compound with the same molecular formula. And we have to try to write one ring containing compound also. The double bond, if based on given formula, the double bond may be present in between carbon and carbon, or that double bond may be present between carbon and any other atom like nitrogen or oxygen. It depends on given molecular formula. If that molecular formula contains oxygen along with carbons, the double bond may be in between carbon and carbon, or the double bond may be between carbon and oxygen also. Otherwise, if carbon and nitrogen also present along with hydrogens, then between carbon and carbon you may expect double bond, or between carbon and nitrogen also you can expect a double bond. So if double bond equivalent equal to 1, we can expect these things. If double bond equivalent equal to 2, for example, after calculations, after substituting the value here, dBe equal to, you got how much? 2. dBe equal to 2 you got. So what it mean? It may contain one double bond, one double bond and one ring. We have to try in this way. We have to try writing structures with one double bond, one ring, or may contain two double bonds, two double bonds. Then may contain, there is maybe with two rings, two rings cycles. Otherwise, it may contain one triple bond also. Contain one triple bond. So, based on this information, we have to try to write different structural formulas. See, here I give one example. First, I'll take one example here. C3H6O I am taking. C3H6O. First of all, what is the double bond equivalent for this? First, you have to find C3H6O. How to find? See here, some means for first carbon we have to find this value. Then after for hydrogen we have to find this value. For oxygen also we have to this value. After adding all these things, we can add 1 also plus 1. Double bond equivalent equal to summation of n into v minus 2 by 2 plus 1. See how I am finding here. Afterwards, we'll write different structures for this also. But first, we should know how to substitute these values here. If you don't know about how to substitute these values in this formula, it is not possible to get double bond equivalent exact value. If you are not getting double bond equivalent value exactly, then after trials also, after putting trials also, you may get there is a chance to get wrong answer. So in examination, sometimes they may ask for given for this how many structural isomers are possible. They may not ask how many chain isomers. Particular individual isomerism they may not ask. How many position isomers or how many functional isomers they may not ask. They ask how many structural isomers. Means we have to include position isomers, then chain isomers, then functional isomers, then metamers, then ring chain isomers, if possibility as per the possibility, except tautomers. So that if you know double bond equivalent, we can go for trials. Without double bond equivalent, if you go for trials, you may get different number, but the total number may not be equal. The total number may not be correct. So if you know double bond equivalent, our trials may be correct. So finally you may get correct answer. So here double bond equivalent DBE for C3H6O. Otherwise index number or index of hydrogen deficiency equal to, see here how many carbons are there? 3. 3 into, what is the valency of carbon? You know, valency of carbon is 4. 4 minus 2. It is over. Carbon is over. Sum no. So I'm adding plus. Then how many oxygens are, hydrogens are there? 6. N value 6 for hydrogen into, what is the valency of hydrogen? You know, it is 1 minus 2 plus, how many oxygens are there? Again 1 into valency of oxygen is, you know, it is 2, not it is group number. Here how many unpaired electrons are present in free state or ground state electron configuration, that you have to count. So 2 minus 2 by, here it will take some space, one more time right here. See D B E equal to, here first 3 carbons, 4 is the valency, minus 2 plus 6 hydrogens total number, 1 is the valency, minus 2 plus 1 oxygen is there, total N is nothing but number of atoms are written, 1 2 minus 2 by 2 we have to do, then after we have to add 1. So what is the double bond equivalent here? DBE for C3H6O. How much it is? 3 into 4 minus 2. 4 minus 2 is nothing but 2 into 3. It is 6 plus 6 into 1 minus 2. 1 minus 2 means it becomes minus 1. 6 into minus 1, it is minus 6. Then here plus 1 into 2 minus 2, 0 only. This is 0 by 2 plus 1. See here plus into minus, it is minus only, no? So directly I am writing here minus 6 minus 6. It is 6 minus 6 plus 0 by 2 plus 1. What value you can get here? Finally double bond equivalent here equal to, it is 0 by 2 plus 1. It is equal to 1. It is equal to 1. For C3H6O, double bond equivalent equal to 1. So by using this, we have to go for writing structural isomers. Means this compound C3H6O may contain one double bond. The double bond may be between carbon and carbon, or the double bond may be between carbon and oxygen also, because here oxygen also present. That compound, this C3H6O may contain a ring. One ring also possible, along with oxygen. Maybe it is one of the ring element, ring atom. Within the ring, we can write oxygen also. Or outside the ring also we can write oxygen. Like that we have to expect a number of structural isomers. See, for this I am writing now different structures. Different structures. See, at one side I will write this formula, double bond equivalent. Here again I am writing formula. See here, DBE equal to sum of n into V minus 2 by 2 plus 1. This is the formula for double bond equivalent or hydrogen deficiency or index number. N is nothing but total number of atoms, like this particular atoms. Then V is the valency in free state, minus 2 by 2 plus 1. That is the formula. So here you got double bond equivalent equal to 1. So we can try now. So here it may contain one double bond. So first for this only I am writing formulas here, structures. So 3 carbons now, I am writing 3 carbons like this. Then this double bond maybe in between carbon and carbon or in between carbon and oxygen. First I am writing carbon and oxygen. A double bond O I am writing, here one hydrogen. Here already around this carbon two bonds are present, so two hydrogens are required here. Here only one bond is present, three hydrogens are required. See now, check once. Molecular formula is same or not. 1, 2, 3. 3 carbons, 3 plus 2, 5 plus 1, 6 hydrogens, 1 oxygen. This is propanol. Propane plus all, propanol. Second, we can write C like this. Double bond O I am writing at the middle carbon. This is ketone. This is aldehyde. First compound is aldehyde. Second compound is ketone I am writing. Here this carbon requires 3 hydrogens. This carbon also requires 3 hydrogens. This is propanone. Propanone is the first member of ketone. Then, so here I tried two compounds in which double bond is present, one double bond is present. So what it means? Here index number or double bond equivalent you got 1 means it may contain one double bond. It may contain one ring. The double bond may be in between carbon and carbon. Double bond may be in between carbon and oxygen. Here I written between carbon and oxygen. See here from this first of all what we have tried, this you should know. Maybe with one double bond. One double bond. This you should know. Or maybe with one ring. Maybe with one ring. This double bond may be between carbon and carbon, or it may be with in between carbon and oxygen also. Like this also we can write. So by using those we have to try. I got two compounds here. Then third compound I am writing, third structure I am writing by using double bond between carbon and carbon. See first I am taking CH2, here double bond, C here H, then CH2 writing OH. CH, see here also, here it is alcohol but unsaturated alcohol it is. Unsaturated alcohol. Unsaturated alcohol. Otherwise we can say 1, 2, 3. There is 1, 2, 3. This from here to left, right to left, you have to give numbering. Because the OH group is principal functional group, we have to give less number for OH group. Otherwise here we can say 1, 2. 2 propanol. Otherwise prop 2 in ol. Prop 2 in ol. Once ol, for ol no number means it should be on first carbon. So prop 2 enol. And we can write in this way also. See CH3, then C, here H double bond C, like this also we can write. But this is enol only, in similar to this, but it is tautomer. It is tautomer. This alpha hydrogen means from this you can consider. This and this both are same. This is a propanol, directly aldehyde group is present. This aldehyde only, this hydrogen, this alpha hydrogen is there, no? This alpha hydrogen is shifted from here to here. In previous classes we have discussed about tautomerism. 1, 3 migration here. So tautomers should not be included in structural isomers because it is a special type of functional isomerism only, so that I am not writing tautomers. If they ask, we can include. Otherwise, should not include tautomers. So here, 2 propanol. Then fourth structure, we can write with respect to ether also, unsaturated ether. So CH2 double bond CHO CH3. Like this also we can write. See here also same molecular formula. 1, 2, 3. 3 carbons. Hydrogens 3, 2 plus 1. 3 plus 3 here 6, 1 oxygen. This is the vinyl group. So this is methyl group. Methyl vinyl ether it is. Methyl vinyl ether. Common name it is. IUPAC name we can write this is ethinyl. Otherwise methoxyethene we can write. This is methoxy group and this is ethene. methoxyethene also we can write. This is one structural isomers, but see, this is functional isomer, this also functional isomer, this is these two means if you write the pairs 1 and 3, otherwise 1 and 4, or 2 and 3, 2 and 4, all they are functional isomers. These two are also functional isomers. And position isomers also we can write. Position isomers, how we can write? Position isomer means if you change this OH group to middle carbon, it becomes tautomer. So tautomer should not be included. So but we can write cyclic isomers now. They are just open chain. Also open chain isomers. Then cyclic. Here I am writing fifth one. CH2. Here oxygen. Here CH2. Here CH2. This is cyclic ether. It is a cyclic ether. This is another compound. One more, sorry. One more compound also we can write, that is cyclic ether only, but epoxide like CH2, here CH2, but here one hydrogen is replaced with one more alkyl, that is CH3. See here, 3 hydrogens, 4 hydrogens, 6, here oxygen. This is epoxide, propylene oxide we can say. Epoxide is propylene oxide we can say. This is the sixth one. We can write one more cyclic compound, seventh one, that is like this. Here CH2, then here CH2, here CH, here OH, like this we can write. This is cyclopropyl alcohol. Cyclopropyl alcohol. See, for all these compounds we have three carbons, 6 hydrogens, and 1 oxygen. So like this we can expect. See, by using this index number, I written one double bond containing compound, the double bond in between carbon and oxygen also. I not considered tautomers here. So 4 open chain compounds you got, and 3 cyclic compounds you got. Because why I written cyclic compound? See, from this what I written, maybe with one double bond, or maybe with one ring. Ring compound also we can write. So that here one ring is there, here also one ring, here also one ring. 2 rings are not possible here, because double bond equivalent equal to 1 only. If we get double bond equivalent equal to 2, then we can write 2 compounds also. Okay, so this is how many? Total 7 isomers, structural isomers are possible for C3H6O. Then I'll give one question for you people. You try on your own. Formula C4H6 I am giving. What is the double bond equivalent? Here I am writing question. What is the double bond equivalent or index number for C3H6? Sorry, C4H6. Sorry. What is the DBE for C4H6 formula? C4H6 formula. Double bond equivalent, otherwise index number first you find. Based on that you can get how many double bonds are present, how many triple bonds are present. From that you can write like these formulas. You try. In next sessions again I will discuss. Just double bond equivalent I am giving here. DBE for this is as per that formula, delta summation of n means 4 carbons are there into 4 minus 2 plus 6 hydrogens are there, 1 minus 2 by 2 plus 1. Right. So here DB, otherwise index number, double bond equivalent 4 into 4 minus 2 means here 4 minus 2 2 into 4 8 it is, minus here 6 into 1 minus 2, this is minus 1, so minus 6 you can get by 2 plus 1. So DBE, double bond equivalent equal to here 8 minus 6 2 by 2 plus 1, it is nothing but 2. You got double bond equivalent equal to 2. So what it mean? So how we can try by using this? So from this we can expect two double bonds, two double bonds. So by using two double bonds, you have to try writing formula or structure. Maybe one triple bond. One triple bond also we can try. Triple bond by putting one triple bond in given molecular formula, that is C4H6. We have to try one triple bond. Or here we can write two double bonds. No, two rings also we can write. But I think here two rings are not possible because only four carbons are present. Then one more is one double bond, one double bond, and one ring combination. One double bond, one ring also we can write. So here double bond equivalent 2 means it may contain two double bonds, it may contain two rings, it may contain one triple bond, it may contain one double bond and one ring combination also we can write. So if you know this, we can try. If you go for trials by using this, you can get exact answer. Otherwise, without double bond equivalent, if you try, you may get some of the isomers, but not exact. Not possible to get exact. Here, by using this, we can go for writing different structures by using these double bonds, triple bonds, cyclic compounds, or rings. So try for this. So please, if you have answer, please send in comment box, please. If you have any doubt, in next sessions, we'll discuss about C4H6. Like C3H6, how many you got? 7 you got, no? 1, 2, 3, 4, 5, 6, 7. Like that, you try to write. This is one of the important question, maybe in NEET examinations, otherwise mains examinations. Okay. In next sessions, we'll discuss about conformational isomerism, geometrical isomerism, optical isomerism furtherly. So one by one we'll discuss. Okay, thank you.